Hey, what's up, guys? It's Alyssa from Medisin, and today we will be discussing the parathyroid hormone. Here we have an image of the thyroid gland, which sits at the base of the neck. If you were to flip over the thyroid, you would actually see 4 parathyroid glands embedded within each of its lobes. The main cell type that we care about in the parathyroid gland are the chief cells. We can remember that these are in charge because they will be the ones that are releasing parathyroid hormone, which now I'll call PTH. The job of PTH is to regulate calcium levels in the blood. Calcium is super important for cardiac action potentials, neurotransmitter release, and muscle contractions. So now let's see how this all happens. The main trigger for PTH release is low calcium levels in the blood. This is called hypocalcemia. Now, when the chief cells in the parathyroid gland sense that hypocalcemic state, they're going to release PTH into the blood. PTH is going to exert its effects on 3 main organ systems: the bones, the kidneys, and the small bowel. Let's start off with the bones. As you might remember, bones have 2 main cell types. The first are osteoblasts, and their job is to build up bone tissue. In response to PTH release, osteoblasts are going to start creating rank L, which is a major regulator of osteoclasts. When these osteoclasts get activated, they're going to break down or destroy bone. And the effect of this is release of calcium and phosphate into the blood. Next, we've got the kidneys. First, PTH is going to trigger the kidneys to activate vitamin D. That is, we're going to take the 25-hydroxy state of vitamin D and convert it into the 1,25-hydroxy state. In the small bowel, the active vitamin D is going to trigger absorption of calcium and phosphate from digested food into the bloodstream, thus increasing calcium and phosphate levels in the blood again. Finally, perhaps the most influential effect of PTH happens at the kidneys, where in the nephrons, calcium is going to be further reabsorbed from the filtrate, and we're going to toss or secrete phosphate into the urine. Now, the effect of all of these different organ systems acting in response to PTH is very simple. We are going to increase calcium levels in the blood and decrease phosphate levels. You heard that. Even though the bones and the small bowel are both increasing phosphate levels in the blood, the effect of the kidney is so great that we're ultimately going to toss the phosphate. And that's how we're going to remember it. The effects of PTH are to keep the calcium and toss the that is, the phosphate. Now, while this entire system is usually triggered by low calcium, and that is the primary driver, it is worth noting that there are some other triggers to PTH release, including low magnesium levels or hypomagnesemia, and severely high phosphate levels or hyperphosphatemia. All of these conditions will lead to PTH, the effects of PTH, and their overall changes in electrolyte levels in the blood.